All right, question 3 on the free response. At Dicey Dave's Diner, the dinner buffet usually costs $12.99. Once a month, Dave sponsors a lucky buffet night. On that night, each person can either pay the usual price or roll 2 fair 6-sided dice and pay a number of dollars equal to the product of the numbers showing on the 2 faces. The table shows the sample space of this random process. Whew, I don't want to be doing 2 6s there. So here's your sample space. You have, well, think about how many options you have. You have 6 times 6. There's 36 different options there, right? So customer decides to play Dave's Lucky Buffet game. Find the probability that the customer will pay less than the usual cost of the buffet. Well, we got to have our total. There's 36 outcomes. So think about how many outcomes would be less than $12.99. So anything, 12 or under would be considered less. So we got, you can just kind of circle them here. All those, that's 6. All the ones less than 12. So basically everything in those 2 columns. Then we got some over here. So if I do that, that's going to be 6, 12. I don't want to count these again. So 16, 20, 21, 22, should be 23 of those would be less than the usual cost buffet. Now, you can just kind of circle on that to show work, but the probability of less than the usual cost would be the probability of less than $12.99, right? Which is going to be 23 out of 36. Or if you want to get a decimal, that's going to be approximately 63.89%. Pretty good, right? All right, moving on. A group of 4 friends comes to Dicey Dave's Diner to play the Lucky Buffet game. Find the probability that all 4 of these friends ends up paying less than the usual cost of the buffet. All right, so now we got 4 people, all independent, because these are random chances to roll die. So we got the probability of all 4 less than $12.99. Would be this probability here, which I'm just going to use the fraction. There's one friend, there's another friend, there's another friend, and there's another friend. Now we don't want to do that. We want to use exponents. So it's going to be 23 out of 36 to the 4th power. So about 16.66%. So the probability of all 4 of them paying less than the usual buffet is 0.1666. All right, letter C. Find the probability that at least one of the 4 friends ends up paying more than the usual cost of the buffet. Well, if you remember from the lesson that we did the other day, we don't want to try to figure out all those possible combinations. The probability of at least one ends up paying more is pays more than $12.99, so 13 or more, is the same as 1 minus the probability that all 4 make less than $12.99. Remember, the probability of at least one is 1 minus the probability of all of them, all 4 pay less than $12.99. Well, we already have that probability there. So it's going to be 1 minus that 23 over 36 to the 4th power, which is 1 minus 0.1666, which is 0.8334. So the probability at least one ends up paying more than the usual cost, right? That's pretty reasonable, because you would think if you had 4 people, then that would be rational that probably one of them would pay at least more than the usual cost of the buffet. So 0.8334. we would want to put these in words. So the probability for this first one, the probability of paying less than the usual cost is 0.6389. The probability of 4 people paying less than the usual cost is 0.166. All 4 people paying less than $12.99 is 0.166. And then finally, the probability of at least one paying more than $12.99 is the same as the complement of all of them paying less than the usual cost. I'm not going to write all that out, but these 3 numbers are what's important here. All right.